Deep learning is a subfield of artificial intelligence that focuses on teaching machines to learn from data in a way similar to humans. Instead of following fixed instructions, deep learning systems improve their performance by analyzing examples and experiences. This technology is inspired by the human brain, especially the way neurons work together to process information and make decisions. Deep learning models use structures called neural networks, which are made up of multiple layers of artificial neurons. Each layer learns different features, starting with simple patterns and gradually moving to more complex ones. One of the key strengths of deep learning is its ability to learn from very large amounts of data. As more data is provided, the model becomes more accurate and reliable. Because of this, deep learning is widely used in applications such as image recognition, speech processing. Neural networks are the core technology that makes deep learning possible. They begin with an input layer that receives raw data, such as images, audio signals, or text. This data is then passed through multiple hidden layers where mathematical calculations take place. Each neuron applies weights to the input and uses activation functions to decide which information is important. The processed data continues moving forward through the network until it reaches the output layer. The output layer produces a final result, such as identifying an object or making a prediction. During training, the network compares its results with correct answers and adjusts its weights. This repeated learning process improves accuracy over time. Slide 3. Why deep learning is important. Deep learning is important because it can solve complex problems that traditional computer programs cannot handle effectively. Unlike rule-based systems, deep learning models are able to learn directly from raw data without needing detailed instructions from humans. This reduces the need for manual programming and feature selection, saving time and effort. As more data becomes available, deep learning models continue to improve, becoming more accurate and reliable over time. This makes them especially suitable for today's world, where massive amounts of data are generated every second. Deep learning also supports automation by enabling machines to perform tasks such as recognition, prediction, and decision-making with high accuracy. It helps organizations make faster and smarter decisions based on data. Because of these strengths, deep learning plays a major role in modern technologies used. Deep learning is widely used in many real-world applications that affect our daily lives. In image recognition, deep learning helps computers identify faces, objects, and scenes with high accuracy. It is used in smartphones, security systems, and social media platforms. Voice assistants such as Siri, Alexa, and Google Assistant rely on deep learning to understand spoken language and respond naturally to user commands. In self-driving cars, deep learning plays a critical role by detecting roads, traffic signs, vehicles, and pedestrians, helping the vehicle make safe driving decisions. In healthcare systems, deep learning is used to analyze medical images, predict diseases, and assist doctors in diagnosis and treatment planning. These applications show how deep learning improves accuracy, efficiency, and decision-making across different industries. Deep learning faces several important challenges that affect its development and use. One major challenge is the large data requirement. Deep learning models need huge amounts of high-quality data to train effectively, and such data is not always easy to collect. Another challenge is the high computing cost. Training deep learning models requires powerful hardware such as GPUs and consumes a lot of time and energy, making it expensive. There is also a lack of transparency in deep learning systems. Many models work like black boxes, meaning it is difficult to understand how they make decisions. This can reduce trust in critical applications. Ethical concerns are another serious issue. Deep learning systems can show bias, misuse personal data, or violate privacy if not designed carefully. Addressing these challenges is essential to ensure that the future of deep learning is focused on building faster and more efficient models that require less data, less energy, and lower computing power. Researchers are working on improving algorithms so that AI systems can deliver accurate results more quickly and at lower cost. Another important direction is human-AI collaboration. Instead of replacing people, deep learning systems will increasingly assist humans by supporting decision-making, improving productivity, and reducing workload. Industry-wide adoption of deep learning is also expected to grow rapidly. Sectors such as healthcare, education, finance, transportation, and agriculture are already using AI, and this trend will continue to expand. At the same time, there is a strong emphasis on responsible AI development. This includes ensuring fairness, transparency, privacy, and ethical use of data.